Hey there, I'm David Cuellar. This is the second video about Zama, and we are going to code a little bit in Rust. We are going to create an encrypted data calculator using Zama's TFHE. So, if you want to learn more about FHE and Zama, just watch my previous video, The Future of Data Privacy with Zama's FHE tools. Harnessing the power of Zama with Rust. First of all, why Rust? And it's because it's 10 to 50 times faster than Python, so the performance is really well, and also they have a very good memory safety. So the fully homomorphic encryption sounds very complex, but Zama makes it very simple. In this project, I will show you how to use their technology in a very small project. The goal will be simplify FHE to developers so they can start building secure private solutions without headache. And the TFHE Rust is a pure Rust implementation of FHE, and we can perform Boolean and arithmetic encrypted data. So in this project, I will show you how to use Zama with Rust. You will get started with Zama's tools, perform some operations, and handle serialization and deserialization. That is very, very important. First of all, let's understand a little bit FHE. So as I mentioned in the previous video, data is encrypted in the transit, is decrypted in processing, and then the response is encrypted again. So for example, we have the number 3 and we have the number 5. If we encrypt the data using this tool, for example, number 3 will be this hash. Number 5 will be this hash. What happens if we want to process the numbers? I mean, if we want to make a multiplication or a division. So if we multiply 3 times 5, it will be 15, right? However, if we multiply the hashes, this times this, we will get an error because it's impossible to process the data encrypted. But now we have FHE. What we can do with FHE is process data that is encrypted, and we can decrypt the result. So in our project, we are going to generate the keys, the client keys, and the server key. We're going to store the keys, we're going to load the keys, and handle operations. This material will be very useful for our project. So I really recommend you to watch a quick 6-minute intro that is here. Also, how operations work in Zama, and how to serialize and deserialize. The requirements for this project: you have to download Rust in your computer, you need to have VS Code, and it's optional to have Warp. Warp because it's terminal that has AI integration, so it will be easier when you have problems and errors. Then let's code. Now we are in Warp in our terminal. So if we want to create a new project, we will just do cargo, new, and TFHE calculator. This is the name of our project. Now that we have it, we just go to our project. If we want to open the VS Code, we will just do code dot. Now that VS Code is open, we will explore it a little bit. So we have here our main. We have here our cargo, right? So in our main, as we saw before, what we need to import our TFHE. So if we go to the documentation, we will see here more information about that. And in the TFHE, they are telling us about the installation. So we have to add this into our cargo tom. So we go to our cargo tom and we add it under the dependencies. When we have that, we are ready to start working on our project. How can we start working in the project? So we can import it in our main. So we will use TFHE, the dot, and we are going to use generate keys. We are going to use set server key, and we are going to use config builder and FHEU int 8, also client key and server key. So for our project, we want to create a CLI, so it will be easier to understand also how this works. So we will create our CLI. We will say .cli equal, and we will create later the structure of our CLI, right? So let's create it now. So to create the struct of our CLI, we will need to type struct CLI, and inside we will have a comment that will have some comments. Some comments here. And the comments that we will have inside will be the key generation. So generate key. And for now, we will add one operation, for example, add. We will add the other ones later. What else do we need? So the CLI need to be parsed. How can we parse? So we need to add a new dependency here that will be called clap, but we don't have it here, right? If we want to add clap, we'll just open this and we will write clap, cargo add clap with the feature derive, just like that. They will find the latest version of clap, and as we can see here, it's already done in our cargo. So we will use it in our project, so clap, and we will use two different libraries. That will be parser and subcommand. Where we will use parser. So in the CLI, we'll need to parse the commands. So derive and parser. And I want to add another one here, a comment. That will be the name equal. And we call it TFHE calculator. Now for our commands, here we will have command with a subcommand. Just like that. Right. And in our commands, we will have subcommands. So derive subcommand. Great. We're done right now with this. So here we will parse just like that. Great. But we already have it in our main, our CLI. But what we are going to do is just match the command that we will use. For example, we will use match. We will borrow the CLI and the command. Commands generate keys. Great. And then here we will use here we will need to create a new function. We will use it later. So the other command that we need is add, just like that. And now we're fine. So as we saw here, we need to generate the keys and store the keys. We are going to create this function. So let's create a function that is called generate keys and store. Generate and store keys. Great. So what we will need to generate the keys, we will need a path. So We'll create a path, and this path will be a string, just like that. We need to configure our client and server keys. To do this, we will use let config equal config builder, that we already have it here. Yes. We will use the default, and we will do build, just like that. Great. What else? We will get our client and our server keys. And we will generate them. Generate keys with the config that is inside, just like that. Great. So we need to serialize the keys. Why that? And it's because we need to transform the data into bytes, so we will be able to save the keys. To do that, we will do let encoded client key. It's a back with U8 inside, and we will use a library called beancode. So cargo add beancode. Great. We check it that we have it here. Beancode. Great. So now we can use it. So it will be beancode serialize. We will serialize the client key. Yeah. And we need to unwrap it. We'll do the same for the server key. Oh. Great. And where are we going to save those keys? So we are going to create a direction, sorry. And to create a directory, we need to add a new library. This new library is called use std fs. And it's called create dir all. We'll create a file. Now that we are here, we'll also use the reader and writer. So IO and read and write. Semicolon and semicolon. std. Yes. So now we have to create dir all with the path that we will pass it here. And if it doesn't work, we will create we will raise a message, a fail message, like fail to create directory. Fine. Now we'll have the files. So the file will be client key file. We will borrow the format and will be the directory, so the path, and then we will call it client key. Oh, client key.bin. Great. We have to do the same for the server key. And now we will write the keys to the files. So let mut file create, and we will use server key file. If we cannot save it, we will use an expect. And we will say failed to create client. Oh. Okay. Okay, we had this error. We need to do the same for the server. Oh, and we need to grade it, of course. So it will be file dot grade all. It will be the encoded client key as slice, just like that. And if we cannot, again on unexpect, so fail to grade key to file. Same to this one, but with server. Nice. So we already generated the keys, and we also stored the keys, right? What we can do is just use the file here. How can we use the file? So we already know that for the generation of the keys, we need to pass a path. So for the path, we will need just to write it here. So it will be a path, and it will be a string. What does it have? So we will use clap with short, long, and a default value equal. We'll save it in temp and TFHE calculator. Great. It will be our path, and here we will use the generate and store keys with path, just like that. So let's try it. We will use cargo run generate keys. It's working fine. So now we can generate the keys, load the key, sorry. So to do that, we will create a function called load key. And inside we will have, so we will let mut file to open the file. So it will be file, open, it will be a path. So the path, we will pass that here as a string. If it doesn't open, we will expect an error that will tell us failed to open key file. just like that. So now we will say mod encode key, and we will create it will be a vector. So vec of u8, just like that. Yes, we'll use back new. Great. So we will read the file. So file read to end, and we will use and mut the encoded key. Great. If we cannot encode it, if we cannot read it, we will say expect, and the message will be failed to read key file. Then now we have to deserialize it. Remember, before we serialize it, now we have to deserialize it. So being code, deserialize, and we will use the encoded key, and everything that is inside. And if we cannot, we will say expect and fail to deserialize key. This helps us to handle any error that we have. Another thing, this will be unequal, sorry for that. Another thing is that this is the output. So what are we expecting in the output? So it'll be like this, where T will be a cert. Now we need to add cert. So cargo add cert. Great. Look at this. This is like reading our minds because it was already showing that we needed cert. So now that we have cert, we can use it. This area is just like this. Great. Oh, it's because we are missing this. Oh, this before the load keys. After the load key, sorry. Now we already created the loading key. So now we are able to start performing operations. So for example, now we can start creating our commands. For example, the addition. So if we want to create an addition, let's start creating it here, and then we will create a function. Okay? So what we will need two numbers. So if we need two numbers, we will add them here. We will call the number, the first number A, the other number B. So A, that will be an U8. Again, clap. And it can be a short long. Great. We need B, that is exactly the same. What else do we need? We need to get the client key and the server key, right? So we'll use a client key path. That will be a string. Clap. Actually, it will be very similar to this. But we will name them. So it will be client key bin. Same for the other one. Great. Great. So we already know that we are going to add here. So we will have A, B, client key path, and server key path. Great. So we are going to handle an operation. The operation will be like this. So first we have to load the keys. So client key equal to load key, and the path will be client key. Great, just like that. Type annotation. Oh, here we already know, it says that we need to know the type. So the type, remember that we loaded this client key and also the server key. So this will be the client key. Great. We will do the same for the server key. But this will be a server key, just like that. And here, great. Now we will have number A equal to, so we need to first try to encrypt the number A to be able to perform the operations. So to encrypt it, we will use TFHE uint u8. Oh, no, int 8. I think it's just like this. Oh yeah. And we will use try encrypt, this one. The value, we will use A. The key, we will use the client key, always. And we have to borrow it. If we cannot load it, what we have to do, we have to always handle the errors. So, failed encryption of A, just like that. We'll do the same for B. We'll encrypt A, encrypt B with the client key. So now we have to set the server key. So we will use set server, set server key. And the server key will be this one that we loaded previously. So now we have to create the operation, right? So let result equal A plus B, just like that. And now look at this. The type of the A plus B is not an integer, it's an TFHE unsigned integer. Now we have to decrypt it, the result, decrypt result, actually decrypted result, type of U8 will be result.decrypt, and we will need the client key. So we need to borrow it. And we can print the result. We'll say result. Great. Let's try it. So cargo run add. First parameter will be 5. Second parameter will be 3. 8 is working fine. So now what we have to do is just pass this to a function. So we'll do handle operation, and we can just copy paste this operation. Handle operation, we will pass all of this there. Borrow U8. We're done with this. We'll try it again. 5 plus 5, 10. It's working fine. What else we can do? So we can see here the types. What types do they have? So they have the negative, we have the addition, subtraction, multiplication, division, and remnant. Let's have this 5. So we'll create this. 1, 2, 3, 4, 5. Subtraction, multiplication, division, and rem. Now we need them here. Oh. 1, 2, 3, 4, 5. Addition, subtraction, multiplication, division, and remnant. So for the division and the remnant, we need to create an assertion because b cannot be 0, right? So to do this, we will just create an assert negative that b cannot be 0. If yes, cannot divide by 0. Same for the remnant. And now we are done. Let's try the subtraction cargo, run subtraction, just like that. In the result we have 15. 10 minus 5 is 5, no 15. Oh. So we have always here an addition. What we can do is just create type function. So how can we create it? We will create an operation, for example, that will be of type of function. The function will have this. I'll get 2, 1, 2, and the result of it will be another 1. Great. And now instead of that, we will do the operation. Okay, great. Here we're having troubles because we are not passing the correct type. So the operation will be just like this. A, B, and it will be A plus B. Great. for the operation of the other ones will be subtraction. Will be multiplication. Division. And here will be the remnant. Now it should work. Fine, the result is 5. We're done. So we're done with the calculator, with the CLI. And if you want to learn more, just go to the documentation of Zama, docs.zama.ai. Also, you can go to the FHE.org, is the community with meetup resources and more. And if you are very interested in FHE and Zama, I really recommend you these 2 episodes of the podcast. Yeah, that's all. Let's continue building together. If you have any questions, if you want to continue learning about the blockchain, cryptography, AI, follow me, subscribe, and yeah, thank you.